Thank you so much for joining this lesson. We're going to discuss Mathematics Paper 2. This is the Alliance Mathematics Forum Examinations 2025 Premock. So you can subscribe to this channel. Remember also to share the link with your friends. Our number is on the screen. That is what you can use to consult. Yeah, please consult through that. As we're going to start with number 1, I will make sure that we finish up with the section 1 during this lesson. Then now, later, I'll schedule another lesson for the section 2. So invite people, just share the link so that you may invite people. As you continue joining the class, be reminded of our platform here, whereby you can purchase airtime from your M-Pesa for all networks, Safaricom, Airtel, Telcom, by just going to your M-Pesa, Lipa na M-Pesa, then the pay bill number is 737356, as you can see it on the wall. Then the account number is your own phone number. You enter it as the account. Then now you proceed to enter the amount, you complete the transaction, and the airtime is going to reflect instantly. Remember, you can also purchase airtime for a friend, whereby you go to the account number. You use the same pay bill, but the account number will be now the phone number of that particular friend that you're purchasing airtime for. Then again, they are going to receive their airtime as well. So let's now get to the paper. I'm on number 1 now. Solve the equation 2x squared plus 4x plus 1 equals to 0 using the completing square method, or completing the square method. Now, in this method of solving quadratic equations, we usually ensure that the coefficient of x squared is 1. That is, you know, the general equation is ax squared plus bx plus a constant c equals to 0. This is the general quadratic equation. Now we ensure that the value of a is equivalent to 1. To ensure that the value of a is 1, we have to divide through by the value of 2, so that we get our equation now as x squared plus 2x plus half. This one is equivalent now to 0. And now we can do away, we can take the constant to the right-hand side, such that we got x squared plus 2x equals to half, which now becomes negative after being taken to, it becomes negative after being taken to the right-hand side. All right, now we are going to add a constant on both sides, and we also a constant on the other side. This constant is added to ensure that the left-hand side is a perfect square. A perfect square is a quadratic expression whereby the terms a, b, and c are related in a way that when we take the value of b and we divide by 2, then we square this, we get the value of c. Remember, it should be c times a, or AC, but now the value of A is automatically 1 here. So we don't have even to multiply there. Actually, the general relationship should be AC. But now it's good to know that the value of A is already 1. That is why it is not going to affect anything here. Therefore, the value of B is 2. So we take 2 over 2 and we square. And you know this is going to be exactly 1. Therefore, we will have x squared plus 2x plus 1. Now, when we add 1, this will be the same as negative half. We also add the same constant to the right-hand side. After this step now, we can factorize the perfect square. Factorizing the perfect square means we just take the square root of this part, which is x, the sign that follows, which is a plus, the square root of the constant, which is 1. So the square root of 1 is just 1 squared. Now, in case we open up this, in case we square 1 plus x, we will get back our perfect square. This is the same as on the right-hand side. Now we shall have half or negative half plus 1, which gives us half. Then from this point, now we take square root on both sides. Taking square root from both sides will give us x plus 1 because it's already squared. Then on the other side, we'll be having plus or minus the square root of half. The square root of half is going to be 0.7071. 7071 to 4 significant figures. So I've approximated the value to 4SF. So the first value of x is going to be, when we take 0.7, this point, sorry. When we take the first option of the square root, which is the positive 1, and we subtract 1, this one is going to give us negative 0.2929. Negative 0.2929. Or the value of x can be, the other option of the square root can be the negative value of 7071. We also subtract 1. This will be negative 1.7071. So those are the two possible values of x. We proceed to number 2, which is a question on statistics. 9 students scored some marks in a random assessment test whose deviations from the mean were 5, -2, 2, 1, z, -3, -2, -4, and 0. Given that the mean of this course is 13, find z and the quartile deviation. Find z and the quartile deviations. So something we're supposed to understand is that all deviations from a mean add up to 0. All the deviations that we are seeing there from a mean score, they usually add up to 0. So when we take 5 and we add a -2, then we add 2, then we add 1, then we add the known z, then we add again a -3, and we add a -2, then we add 4, and we add 0, we expect to get 0. So now through combining all these terms, then we take them to the right-hand side, you discover that the value of z is exactly -3. So now all the deviations now can be listed as 5 - 2, 2, +1, and instead of z, we have a -3 there. So that is the value of z. After getting the value of z, now we are proceeding to find the quartile deviation. Before we get the quartile deviation, we are supposed to get the specific scores of these students. Remember, a deviation is given by what a student has scored minus the mean, because these are deviations from the mean. Deviations from the mean. The first student is deviating from the mean by 5 marks. And you know, this now means we can get the student's mark by saying that if this is so, then it implies that we can get back our x, which are the individual scores, by taking the value of each deviation and we add the mean. Yeah, that is the mean. We add back the mean. So the first student will be having a mean is 13 and is deviating from the mean by 5. So he's having 18. The next one is going to have 11. Just like that, we are adding a -2, so it will be 11. The other one will be 15, then 14, then 10, then 10 again, because of -3, then -3. Then we will get back our 11. Then with -4, it means the person is having 9. Then with a deviation of 0, that person was having exactly 13. So he got the mark, which also became the mean. So these are now the individual scores. This means now with the raw data, we can now compute what we call the quartile deviation. And for us to get the quartile deviation, which is also called the semi-interquartile range, we need what we call the lower quartile, the upper quartile, or rather the Q1, the Q2. These are only achievable when the data is arranged in ascending order. So we begin by the least data, which is the least value, which is 9. Then after 9, we can talk about 10, but 10 is occurring twice. Then we go to 11, which is also occurring twice. Then we'll have 13, 14, 15, and 18. These are now the 9 students and their marks. Now, with the data that way, we can find, first of all, the median mark. The median mark is the mark which is at the center, at the middle. So 1, 1, another one from this side, another one from the other side, until we find the value at the middle position. So at the middle position, we are having 11. So 11 is the median, which we are also calling the Q2. Q2 is 11. What about Q1? After median has splitted data into 2, we have the lower set of data, the upper set of data. Now, the median of the lower set of data is what we call Q1, or rather the lower quartile. So the lower quartile is going to be the median of these values. So the median of these values is going to be, we have 9, 11, then at the middle, we have 10 and 10. So the average of 10 and 10, the average of 10 and 10 is going to be 10. So Q1, the lower quartile, is 10 plus 10 over 2, which is just 10. Then now we are supposed to find the Q3. Q3, or rather the upper quartile, is usually the median of the lower set of data. After median has been identified, now we are having the upper set of the data. So we need the median for this upper set of data, whereby you can now say there is 13 here, there is 18 here, and at the middle, we are having 14 and 15. So we have to take their average because they are both at the middle positions. So we take their average, whereby we will say that Q3 is going to be 14 plus 15 divided by 2. And this is going to be 14.5. So Q1 is 10, Q3, 14.5. After that, now we proceed to calculate what we usually call the quartile deviation. So quartile deviation is going to be given by Q3 minus Q1 divided by 2. Q3, 14.5 minus 10. Then we divide this by 2. When we divide this by 2, we shall get exactly 2.25. 2.25. So that is what we call the quartile deviation. There is a question in number 3, which is on errors and approximations. Given that the values or the value y lies between positive 8 and positive 12, then the value of x lies between 1 and 6. Find the maximum possible value of y plus x divided by y minus x. What you're supposed to understand is that we are talking about maximum possible value. So what kind of a value is it? This is a quotient. So you're supposed to know that maximum quotient, because it's a division being applied, maximum quotient is usually given by maximum numerator then minimum denominator. Then what nature of a numerator are we having? The numerator is a sum. So maximum sum is given by sum of the upper limits. Sum of the upper limits of whatever values are being added. We need the upper limits, their greater values. What about the denominator? The nature of a denominator that we are having is a difference, and we need it to be minimum. So minimum difference. Minimum difference, this is what will occupy the denominator now. Minimum difference is given by minimum, the lower limit, let me call it lower limit of the first value. But on the other side, we subtract the upper limit for us to have a minimum, difference, yeah. The upper limit from the other side. So applying these tips, we will need, because the numerator is a sum, we need the maximum sum, which is going to be sum of the upper limits. That will be 12 and 6 from both sides, 12 and 6. Divide by a minimum denominator, and the minimum denominator is contributed by a difference, whereby we need the lower limit for y, which is 8, minus the upper limit for x, which is a 6. You see, at the end of the day, we are having 18 divided by 2. And this is going to result to 9. So that is the final answer, 9. I think students are supposed to really understand what is happening there. Look at a wave question here, which is a trigonometric wave. The figure below represents the curve of the function y equals to 1 plus a sine of wx minus 45 degrees for the range 0 all the way to 720. So here is the drawn wave. Part A. Determine the values of a and w. The value of a, which is just before the sign, is usually amplitude. A is for amplitude in this case. And amplitude is the highest the wave can raise to when it has been drawn according to the vertical displacement. Therefore, you can see the highest this wave can go to is at 4. Therefore, the value of A will be 4. Then now we can talk about the value of W. We need to discuss that. The value of W. Therefore, we're supposed to know this, that there is something called the wavelength of a wave. Wavelength, okay, not even wavelength, sorry. Let's talk about period. Yeah, let's talk about period. Sorry. Period T of a wave in mathematics. The period is usually given by the difference between two particles along a wave which are in phase. You know, that is some physics language now, where I would expect learners to catch up because it is physics form. It's physics form 2. Yeah. And for you to do mathematics paper 2, you should have already passed through form 2 physics. So if we move from, for example, here, from 120, for us to cover a complete period, we have to move. The wave is having this direction. So if the wave is moving and it passes through a point here, that is at 120, for it to complete a whole cycle, that is after covering a whole period, it should move until it is at the same position and moving in the same direction. So that is at a point like here. So from now 600 all the way to 120, that difference is what we call the period of a wave, which will be given in degrees. So 600 minus 120, and this is going to give us 480 degrees. So the period T is 180. Yeah, 180. That is something you're supposed to know. 480. Look at, you can get it from any 2 points which are in phase. You can even move from 60 until you are at the same position and moving in the same direction. You know, the wave I said is in this kind of a direction, So when we say that we are at this position, we cannot rely on that, because let me show what I mean. Getting back to that, sorry. Yeah, this is where we are. So I'm saying, if we move, you know, we had already considered 120 all the way to 600. So we can still consider 60 all the way to 540. From 60 all the way to 540. And you take 540, you minus 60. I'm still getting 480. You can still consider 180 from this point all the way to 660, that point. That is still another complete wave. Therefore, you are confirming that the periodic time, the period of the wave T is 460. So when we have a period of 460, there is something you should get back to and ask ourselves. If a function is y equals to a, the sine of wx plus or minus a certain angle, then there are a few things that we're supposed to conclude from this general equation. That a is usually amplitude, then the absolute value of the angle here is usually giving us the phase angle. So the phase angle is going to be absolute value of the data provided there. But now we have W here, whereby we say a period is usually given by 360 out of the value just before X, out of W. So the period, which we are already concluding to be 480, the period of 480, I'm sorry for that, the period of 480 is given by 360 out of W. So to remain with W now, we should talk about 360 out of 480, and this is giving us 3/4. Yeah, or 0.75. So the value of W, we said A is amplitude 4, and W is now equal to 3/4. Very serious. So that is what you're supposed to know. 3/4. State the phase angle of the wave. So looking at the wave generally, the phase angle will be absolute value of the angle there. Even if it is negative 45, we just say that the phase angle equals to 45 degrees. You pick it the way it is. Let's look at a logarithm function here in number 5. Solve for x in the equation of the logarithm of 81 to base 2 plus logarithm still to base 2 of x minus x over 3 is equivalent to 1. we shall be applying a few laws of logarithms together with indices until we see the possible solution to this particular question. All right. We'll say this at the first place. Whenever we have n, the log of a, this is usually solved by taking the logarithm of a, but we raise it to power n. We raise it to power n that way. Yeah, then again, we also talk about, the question can have several approaches, but kindly bear with my approach for now. You can still try other workings. There is also another law of logarithms that says when we have the log of a certain number, say a, to the same base, this usually gives us the value 1. And because base 2 has been used here, then we can introduce log of 1, log of 2 to base 2 instead of 1 on the right-hand side. Therefore, this equation can be rewritten. It can be rewritten as the logarithm to base 2 of 81. Now 81 becomes power half because of the first law that we've recorded there. Then this plus the logarithm to base 2, x squared minus x over 3. Then this can be equal to the logarithm, because of the second law, the logarithm of 2 to base 2. Yeah, that way. Now, when we apply further laws, more so on indices, you discover that this can become the logarithm to base 2 of 9 instead of 81 now, because 81 power half means we take the square root of 81. Yeah. Plus the logarithm to base 2, x squared minus x over 3, equivalent to the log of 2 to base 2. At this point, you will allow me to quote another law of logarithms that says if case we have log of a plus the log of b, as long as they are logs to the same base, then we can solve this by taking log a multiplied by b. And applying this on the left-hand side, we just need to take log to base 2. Then we will have now a multiplication of 9 and x squared minus x over 3. Yeah, that way. And this can be equated to the log of 2 to base 2. That way, the log of 2 to the base of 2. Now, again, let's talk about, the laws have fully been applied now. So we can equate the right-hand side and the left-hand side, whereby we will drop logarithms now and talk about when we open brackets here to be 9x squared minus 9x over 3 being equivalent to 2, because log to base 2 has been dropped. Don't cancel it, just drop logarithms. Okay. Now, if I have to, rearrange this equation, you discover that this is 9x squared minus 3x, and this is just equivalent to 2. Yeah, it's equivalent to 2. So with that, we can start talking about a quadratic equation, which can be solved in the very many methods. We have completing square, we have factorization. Allow me to try factorization, because completing square has been used in number 1 in the same paper. So I'll be talking about minus 3x minus 2 equals to 0. Now, applying factorization, we need a product of a and c. So a product which is equal to negative 18, and a sum which is equal to the value at b, and that is negative 3. Therefore, two factors, when multiplied, negative 18. When added, negative 3. And that will be negative Okay, positive. You're having negative 18 and negative 3. So negative 6 and positive 3. Yeah, negative 6 and positive 3. So now we are going to rewrite the equation such that we have 9x squared, and instead of negative 3, we'll have negative 6x and positive 3x, then minus 2, equivalent to 0. From the first term, the first two terms, we can factorize 3x. So that will remain with 3x again, minus the value of 2. Then we add, it's only one which is common here, in bracket 3x minus 2 equals to 0, that way. So we can pick the common factor in the brackets, that will be 3x minus 2. Then outside the brackets, we're having 3x and a positive 1. This is equivalent to 0. So for us to get the values of x, we're supposed to say 3x minus 2 equals to 0, and also 3x plus 1 equals to 0. So 3x minus 2 equals to 0, or 3x plus 1 equals to 0. From the first case, 2 becomes positive on the right, so that the value of x is positive 2/3. Then on the other side, we will have x becoming negative 1. So when we divide by 3, we get negative 1/3. So these are the two possible values of x. Yeah, the two possible values of x. Two possible values of x. Number 6. Remember, our consultation line is a 0704153366. That way, reach out to us through that. Find the area of the region bounded by the curve y equals to x power 3 minus x, and the x-axis between the points x equals to 3 and x equals to negative 1. This is negative 3, sorry, not 3. When we are talking about a find area, this one should be the exact area. We have not been taught to estimate the area. Therefore, we cannot go to the methods of estimating area. We have to work fully with area by integration. Something that I advise my learners to do about area by integration is that you should never attempt applying integration on a function which you have not plotted within the provided domain. X equals to negative 3, x equals to negative 1. So the first thing you do, just sketch this curve. We are having x and y. From negative 3, go to negative 2, then go to negative 1. Let's see, how is the curve behaving? How is the curve behaving within these limits? So at negative 3, when we substitute here, it will be negative 3 cubed minus a negative 3. So I have to do that now, negative 3 raised to power 3. Then I subtract negative 3. This is giving us a negative 24. Then we talk about negative 2 also. So negative 2, we raise to power 3. Then we have to subtract a negative 2. This is giving us negative 6. Yeah, negative 6. Let's talk about negative 1 now. So when negative 1 is placed there, it will be negative 1 power 3 minus a negative 1. You know, negative 1 power 3 remains negative 1. But when we subtract a negative 1, it becomes negative 1 plus plus 1. And this is going to become a 0. So looking at these values, you will discover that the curve behaves this way. This is how the curve behaves between the limits which have been provided. This is how the curve behaves. From 0, we have a negative 1 here. We have a negative 2. There is a negative 3. So the coordinate for negative 3 is negative 24. For negative 2, we have 6. And for -1, we will have 0. Yeah, that is how they have it. So if we have to sketch it now, you know, the curve is going to be this way. That's how the curve is. So following the x-axis and the provided lines, x equals to -3, which is here, and x equals to 1. So the area will be this one. And when you look at this area, you discover that it lies on the same side of the x-axis. There are some times whereby, with given limits of x, the area that we are talking about is going to lie within the lower side of x-axis and also the upper side of the x-axis, such that it is split into 2. For example, area that behaves this way. You know, from this value, area can be here. And as you continue up to this value, the area is changing now its location to the upper side, and it is within a given limit. Therefore, with that, you're supposed to integrate twice. But for our case, the integration will only happen once. Yeah, you integrate once. We integrate once from -3 all the way to -1. From -3 to -1. So I just wanted to see the behavior of the curve within the provided limits of x, and we have examined and found that the area is on the same side of the x-axis. Therefore, now I have confidence that we are going to find the area by integrating from -3 to -1 the function x, power 3 minus x with respect to x. Yeah, so that is how we are going to do it. So when we integrate this, we shall have 1/4 x power 4, because x has to increase, the power of x has to increase. Then we divide by the new power. So we get 1/4 here, and x going to power 4 minus x is to power 1, so it changes to power 2. So x becomes squared, and we divide by half that way. Remember, the range remains from -3 to -1. Remember, the bigger limit here is -1. So we'll begin by substituting -1. Then we subtract the same function after substituting -3. So we start with 1/4 into -1 power 4 minus half into -1 power 2. That is it. Then after this, we subtract, when we use the lower limit now, 1/4 into -3 power 4 minus, we can talk about half now, then -3, which has been squared. Yeah, -3 squared. So let me work out this. 1/4, when we subtract half, I think that is what you should know, we get -1/4. 1/4 minus half becomes -1/4. Then from the other case, we'll be subtracting. When we take 1/4 into -3 power 4, then we subtract half into -3 squared. We are getting 15 3/4. 15 3/4. So when I get 15 3/4, yeah. So now this one is going to become, at the end of the day, we check, it's going to become -16 at the end of the day. -16. Now, the negative behind 16 is just emphasizing that the area that we worked out is on the lower side of the x-axis. but the value of the area is the absolute value of what we are getting there, the absolute value of the integral. Therefore, we talk about 16 square units. So you take the absolute value. The negative is just to indicate location of the area. When you get negative area after integration, that area is on the lower side of the x-axis. And according to the sketch that we had, we could see that truly it was on the lower side of the x-axis. Number 7, sorry, not 17. Expand and simplify. Expand and simplify. These are binomial expansion. 3x minus y raised to power 4. Hence, use the first three terms. That is very key. The first three terms of the expansion to approximate the value of 6 minus 0.3 raised to the power of 4. Now, there is something I want you to notice here, because the instructions are very key. We are expanding and simplifying the whole binomial expression. But now, in the expansion, but now in the approximation of 6 minus 0.2 power 4, it is when we will use the first three terms. So we are not expanding and simplifying the first three terms. It is in the application. So in our expansion, we will use all the terms that we get when the power is 4. So we start by listing the coefficients, the binomial coefficients, or the Pascal's triangle coefficients when the power in a binomial expansion is 4. These ones are found freely in the mathematical tables. I think page 27 of the same. They when the power is 4, we're going to have 1, 4, 6, 4, and 1. So 1, 4, 6, 4, and 1. Yeah, that's how they are going to be. Then in the first, we will have 3x raised to the power of 4, but negative y will be raised to the power of 0. But as we continue moving along the terms now, the powers of 3x will start going down to 3, as those ones of negative 1 start ascending from 0. In the next term, we'll have 3x being squared, but negative y ascends to power 2. Then here we'll have 3x taking a power 1, yet negative y goes to power 3. And finally, 3x will take a 0. 3x will take a 0 as negative y assumes power 4. Yeah, that's all. Then now we can now expand. When we start expanding, in the first term, we will get 3x power 4. That becomes 81. X is to power 4. Remember, negative y power 0 becomes 1. So everything is just 81 x power 4. The term which follows will begin with a minus, because negative y raised to power 1 remains the way it is. So we'll be multiplying when there is an existing negative there. Now, 3 power 3 is 27, but this has to be multiplied by 4. So 27 by 4 will give us 108. 108, x is to power 3, but y is to power 1. That way, the next term now will have to be positive, because negative y is being squared. And when it has been squared, now it becomes y squared. The negative disappears, because negative y times a negative y becomes positive y squared. 3 is to power 2, that becomes 9. Then there is a 6 here, and that will give us 54. X is now squared, and y is also squared. The next one we'll have to start with a minus, simply because negative y power 3, there is a negative which is going to remain. Negative y times negative y, negative cancels. But when you include the third negative y, the negative comes back again. Then now 3 power 1 is 3. But now when we multiply by 4, it becomes a 12. X is to the power of 1, but 3 is now cubed. Finally, we will have to add because negative y power 4 becomes y power 4. Yeah, it becomes y power 4. And after it has become y power 4, you discover that 3x power 0 becomes 1. So it will be 1 times y power 4. You see now? So the negative has disappeared. When we are raising a negative number to an even power, the negative disappears. When a negative is being raised to an odd power, negative is retained, because when power is even, there is always another negative value to cancel every existing negative. When the powers are odd, when the number of the index is odd, when the index is odd, you discover that, I'm talking of this odd, you discover that there is always one number which will remain alone, and the negative will have to be retained. Now we have expanded. After this expansion, we are to use the first three terms to determine the value of this. So we will say this, 3x minus y raised to power 4 is the same as 6 minus 0.2 power 4. And because the power is the same, we can equate the bases. 3x minus y is equivalent to 6 minus 0.2. So with this now, we can equate corresponding values or corresponding terms. So 3x is equated to 6, whereby x becomes 2. Negative y is equated to negative 0.2, not 0.2. So that the value of y becomes 0.2. Then now we take them back to our expansion up there, whereby we will say we need 81 into, instead of x, 2 power 4 minus 108 with a 2 power 3, but 0.2 power 1. Then we add 54. Now 54 will be having 2 power 2 and 0.2 also power 2. Then after this, we will subtract 12 with x, which is 2 power 1, but 0.2 takes power 3. And finally, 0.2 will be raised to power 4. So when we use a calculator to compute this, we shall get exactly 1131.84. So you use a calculator to work out all this, and you get 1131.84. 1131.84. Number 8 is on probability. Question says, a box contains 3 brown and 15 white cloth pegs. The pegs are identical except for the color. 2 pegs are picked at random, one at a time without replacement. Find the probability that, part A, a white peg and a brown peg are picked, that is. Remember that we are picking without replacement. Again, we just need a white peg and a brown peg to be picked, and the order has not been specified. Therefore, we need probability, picking white and brown peg. This can also be probability, brown, then white. So any can come before the other. So if we talk about white then brown, we will be having, in the first picking white is going to be 15. out of the total of 18 multiplied by picking brown, which is going to be picking. When you have picked white, the number of browns has not been affected. So browns have remained 3, but now it's out of a new total, which is 17. That is what you're supposed to know. Or means addition in probability. When you pick brown, that is going to be 3 out of a total of 18. Then you pick white. You didn't replace. But now because you picked brown, picking white will remain 15, but the total has been affected due to not replacing 17. Yeah, that is what you're supposed to know. So we get 5 over 17. 5 out of 17. Remember, this question can still be solved using a tree diagram. But now that we can understand the values provided, then it becomes very easy. The second part of the same question. Both pegs are of the same color. Probability that both pegs are of the same color. This means probability picking white, then white, or probability picking a brown, then brown. Remember, it is without replacement. Therefore, picking white, according to the information that we have, whites are 15. So picking white is 15 over 18. But because you didn't replace, picking white in the second round of picking now, we go down to 14 out of a new total, which is 17. Or, which means addition, probability picking brown is 3 out of 18. And if you fail to replace, picking brown again should go down to 2 out of a new total of 17 because you didn't replace. Yeah, this is going to give us exactly 12 out of 17. 12 over 17. So that is what, so you're supposed to operate such a simple question. Now we are at number 9. It's a graphical question. We can read it together. The Ministry of Health made an order of both AstraZeneca and Johnson & Johnson vaccines for a health center in 2020. That was during the corona period, you know. X represents the number of Johnson & Johnson boxes, and Y represents the number of boxes of AstraZeneca. Those are the vaccines for the COVID-19. Look at this now. Information. X plus Y is greater than 600. Actually, inequalities have been formed, but now the statements which are represented by these inequalities can still be traced. We can say that now here the boxes of both Johnson & Johnson plus those of AstraZeneca, they were supposed to be more than 600. Again, the number of Johnson & Johnson boxes is supposed to be less than 500, while the boxes of AstraZeneca is supposed to be less than or equal to half. Less than or equal to half the number of Johnson & Johnson, which is X. So that is why we have these inequalities now. Represent the inequalities on a graph. The graphs of inequalities. When the sample is strictly greater than or strictly less than, we have dotted lines. So we're going to use a dotted line at that point. That is what you're supposed to know. Then on the other side, there's something we should know. When the inequality sample is less than or equal to or greater than or equal to, we usually use complete lines. So for the last one, this one, we use a complete line, a complete borderline. But for these two, we'll use dotted lines to represent the inequality. Dotted lines. Those are the basic information that we should be having as we handle these topics. Now we're going to have the axis here. That is the vertical axis. That is the y-axis. Then on the x, we need to talk about where the x-axis will be here. Good. So from 0, we can talk of 100, 200, 300, 400, 500, 600, 700. Can reach there first. Then now we can have again the x-axis. Yeah. So far that labeling is enough. The first borderline, when you talk of x plus y greater than 600, then we can, x plus y, sorry, we usually change the inequality to the borderline. So there is a borderline that represents each inequality. The borderline for the first inequality will be x plus y equals to 600. So we can take some values here, whereby when x is, for example, 100, what will be the value of y so that they give us 600? This will be 500, of course. When x is 200, for them to give us 600, values of y should be 400, 300, 300. So that they give us a total. We just fill a table like the normal graphs of lines, straight line. Therefore, 100, 500. So 100, 500 to be this coordinate. Then 200, 400. 200, 400 will be this one. Then we can also talk about 300, 300, which is going to be here. Those are enough coordinates already. And something that you're supposed to note is that we will use a dotted line for that particular inequality. So we use a dotted line to do this inequality. We use a dotted line. What is it? So we have the dotted line now. It might not have been very accurate. Let me check something here. Let me redo this. Let me just redo that. I want to place my ruler very well so that we have an exact line. Yeah, that way. So that is the line for the first borderline, which is borderline y plus x equals to 600. Yeah, that is it. Now, the second one is going to be x less than 500. So this one is x equals to 500. So on the axis, on the x-axis, we go to 500. And we just draw a vertical line there, but it's going to be dotted. X at 500, and we remember that it shall be dotted. So let me use a different color. I employ green this time around. So this is now the borderline. X equals to 500. That is the borderline. The third and the last, y less than or equal to half x. So y equals to half x. So we can get a value here, some 3 coordinates. When x is 200, the value of y will be half this value. So 100. When x is 400, the value of y is going to be half 400, which is 200. when the value of x is something like 500, the value of y is going to be 250. So we can pick any values of x so that the values which are corresponding for y can be now found using the equation. So now we need 200, 100. So 200, 100, this one. We can also talk about the next value whereby 400 goes with 200. This is the coordinate. We can also talk about 500 and 250, which is here. 600 would go with 300, like that. So the values are unlimited. So let's do this graph now. And allow me to use a different color here. So when we do this line, remember it's going to be a complete line now. This is the third borderline. And this borderline is given by y equals to half the value of x. So now with the borderlines, you can see that, okay, what are we going to shade first? What we're going to shade is that represent the inequalities on a graph. Okay, you know, sometimes you can shade the required region, some other times they are required side, so that we may see the region that we need. But the region which has been bounded by the region bounded by all of them is here. The region bounded by the three borderlines is here. That is the region which has been bounded by the three lines that way. So with the region now, we can check what part B is talking about. If the cost of importing one box of Johnson & Johnson is 1,000 and AstraZeneca is 800 Kenya shillings, find the maximum cost of importing the vaccines by use of a search line. Very important, by use of a search line. So we begin by identifying search line. We begin by getting the search line. Remember, X was Johnson & Johnson. So Johnson & Johnson is 1,000 times X plus Y by 800. So 800 by Y. This is called, you know, this will be equal to a value P. This is called the objective function. It's good we learn some linear programming. Objective function. Now, it is from an objective function that we obtain what we call a search line. So the search line, is going to have a y-intercept, which is equal to 1,000, and an x-intercept, which is equal to 800. So we usually interchange this. If the coefficient of x is 1,000, then we need a y-intercept of 1,000. If the coefficient of y is 800, then we need a x-intercept of 800. So that is the swapping that we do at that point to get a search line. So now, looking at what we have here, we may discover that these values are too many, too large for the coordinates used here. And if they are so, we can use a common scale to make them smaller values, like dividing through by 100. When you divide by 10, sorry, not even 100, divide by 10, so that we get y-intercept equivalent to 100 and x-intercept equivalent to, so that they may be realistic according to the scale used. So we need a y-intercept of 100 and an x-intercept of 80. Then we draw that line. It will be called our search line. So our search line now will pass here. Our search line is going to pass here. Yeah, it's our search line. Now with the search line, let us talk about how to identify the maximum point. So we are going to slide using a set square and a straight ruler the search line into the region such that we get into the region. So we'll be sliding it such that the ruler is parallel. So we'll slide this set square. We'll slide the ruler such that this search line is introduced to the region. Then we identify the coordinate, which is going to be the last within the region, and it is within the required region. So when we look at the region, a coordinate is not supposed to lie. A coordinate is not supposed to lie on the, it is not supposed to lie on the borderline here. So this borderline, it cannot lie there. And we have the first borderline here, which is also dotted. You know, when a coordinate lies on a dotted line, it is just on the borderline, but it's not among the required ones. So the borderline can strictly lie on this last borderline here. It can lie there, but not on the others. Therefore, when you look at the very last, we will be talking about coordinate 500 and 250 according to the region that we have there. But now that one will not be acceptable. Therefore, we have to get now into the region and talk about a coordinate like 499. That is still a value just before 500, 499 and 240. Just before 250, we can talk about 240. So 499 and 240. And 240. That way, we will be, okay, 249, sorry, and 249, yeah, and 249. That way, we will be in there. Or we check with the 249. What are we going to have as the value of y? That is when we consider the points on the required region. So we'll be having 499 and 249, slightly before that region. So now with this, then we can talk of 499 by 1,000. Then we add 249, 800. What are we going to have? So I'm supposed now to compute this. Whereby 499 multiplies 1,000. Then I add 249 multiply 800. is going to give us 698, 200. This is now the maximum cost of importation. Yeah, that way. Number 10, this is a question on commercial arithmetic. The table below shows income tax rate for the year 2025. So we can see the monthly income, and we can also see the corresponding tax for every bracket. Given that the monthly personal relief was 2400 Kenya shillings, and that Macau's monthly tax after relief was 3,000. Calculate Macau's monthly income. So before we go to the monthly income, let's talk about his gross tax. Now, gross tax is going to be the net tax that he pays plus relief, and that will be 5400. So this one, is it 5400? No, 10, sorry. 54 two zeros. Sorry for that addition error. That way. So this is the total tax that he would have paid if it were not for the relief. So now we should know that we are going to tax a known amount for Mr. Macau until we get a total tax of 5400. From the first bracket of taxation, we have 24,000. 24,000 is being taxed at the rate of 10%. And this will give us a tax of 2400. When you look at 2400, you discover that 2400 is not yet 5400. So we continue taxing. In the second bracket, you know, we have to take 33,000 and we subtract 24,000. That will be 9,000. Is that right? Yeah, 9,000. At the rate of 25, sorry. The rate now is 25%. So you're supposed to be very careful. So when you multiply this by 25%, you discover that the tax here is 2250. 2250. Remember, we have a maximum tax of 5400. So when we gauge the amount fully, which is in the third bracket, we'll be taking 60,000 and we subtract 33,000. That will be 27,000. Now 27,000 at the rate of 30%, we'll get 81,000. So we don't need all that tax, or rather, Kamau is not going up to 60,000. Kamau is not going up to 60,000. Macau, that is. It means that Macau is being taxed up to this third bracket. But now there is an amount that we don't know, whose tax should be added to the total that we have so that we get 5400. So we are supposed to know that the amount remaining in that bracket is when we take 5400 and we subtract from the first bracket 2400 and 2250, and this is 750. So what remains is only 750 as tax, so that when we add everything here, we shall get 5400. Yeah, that is it. So now there is an amount which will be taxed at the rate of 30, a known amount at the rate of 30%, and this will give us 750. So which is this amount that has to be taxed at the rate of 30% to give us 750? 750 should be multiplied by 1,000, by 100 over 30. That will be 2500. So X is 2500. Yeah, 2,500 is the amount of X now. the value of X. So the total monthly income, which was taxed, the taxable income, which is the monthly in this case, is going to be from the first bracket 24,000, second bracket 9,000, the last bracket 2,500. Now we get a total of Kenya shillings 35,500. $35,500. Yeah, that way. Number 11, we are talking about this is basic construction together with the loci. Paper 2, mathematics. Using a ruler and a pair of compasses only. This instruction now means it is throughout the whole construction that we are going to use a ruler and a pair of compasses only. Construct a triangle ABC such that AB 6 centimeters, BC 8, the angle ABC 60. So AB 6, I begin with 6 centimeters. So AB 6 centimeters. So A to B, we measure 6 centimeters. Then after this now, at B, we construct 60. Remember, I'm just illustrating. So standing at B, I have to make an arc using a reasonable radius. Then standing at this point where the arc is catching the line, I make another arc up there. So that after producing that arc now, I can do a line through there, and that automatically becomes an angle of 60. This is automatically now 60 degrees. With that, we know that BC is 8. So use an arc of 8 centimeters to mark off point C. 8 centimeters that way. So now you can drop from C to A for you to get this way. So we are having the triangle now. We proceed to part B, where more instructions are provided. Locate the region R by shading such that the angle BRC equals to 60 degrees. Now this is called the constant angle loci. So for us to come up with a constant angle loci, we need to know that we use a chord BC. Then we are supposed to construct a circle whereby we can subtend an angle of 60. For us to be able to construct an angle of 60, according to angle properties of a circle, we need a center. We need a center where we can construct double that angle. So we need 120 at the center. And for us to construct 120 at the center, it means we should have base angles. You know, at the circle, we have 60. So at the center, we talk about double this angle. That means we need base angles. For us to have 120 here, we need some base angles here which are equal, and they should be equal to 60 divided by 2, which is 30, 30. So we need that 30. This should be constructed without they should be constructed without the engagement of a protractor. Therefore, standing at B, I should construct 30, and also standing at C, I construct 30 on both sides, because we have not been limited to the side where the region is. In case the side had been specified, we would have stuck to the same side. But now we have to construct on both sides, now that the instructions are open. So we stand at B, and we make an arc. Then standing at this point, we cut the arc. Then now we have to bisect now. You know, when you bisect 60, you automatically come up with 30. So with that, this will automatically become 30 degrees. And remember, we can do the same for C, though there are different options whereby you can bisect BC, because BC being a chord, the bisector of a chord must pass through the center. So the intersection of the chord bisector, and the angle of 30 will also identify the same center. But we can just construct, standing at C, we make an arc, then standing on the arc, we cut it up there. Then again, we have to bisect this angle, which was 60, so that we come up with 30. See now, we have 30 here, we have 30 at this other point. So where we are intersecting, definitely this will be 120. Now, if this is 120, we have to use the angle, that center, then the radius, center is O, we call it O1, that center and the radius O to C, so that we may construct now the constant angle loci. Yeah, we have a constant angle loci like that one. A constant angle loci. That way. So if we can construct 120, then along this particular circle, we can construct our 60 degrees. So for us to have 60 degrees or more than that, remember inequalities have been used here, or more than that, for us to have 60 or more than that, you need to know that we need the inner side, because if we go beyond this circle, we will have an angle smaller than 60. And we do the same on the other side of BC. We do the same on the other side of C, whereby we can bisect this 60 so that we get that in 30 that way. Then after getting that, you can bisect length BC, so that the perpendicular bisector of BC will automatically pass through the center. So this center will be called O2. With center O2, we now stand there. And again, we do a similar constant angle loci using this center and the radius O2B. This becomes the radius now. We have to do another constant angle loci on this other side. Yeah, so the constant angle loci now goes to the other side. Any of them will suit this instruction. Then the next one is a BR greater than or equal to RC. So BR equal to RC, we need to bisect the length BC. We need to bisect the length BC, which is here, and it should be a complete bisector because it is greater than or equal to. So this bisector now will now be used. That is the bisector. And now that B to R, you know this is R now. So B to R is supposed to be greater than R to C. So we need the upper side. From this one, this is the side we want, this is the side we don't want. Because when we consider the side below, then BR will start becoming smaller. So R is beyond this line. R is beyond that line. Then finally, RC less than 4. So RC equals to 4. It means we need a circle, but because it is strictly less than, we use a dotted circle. A dotted circle. A dotted circle. But using the center C. We use C as the center. C is the center to do a circle, which is dotted, and a radius of 4 centimeters. A radius of 4 centimeters. a radius of 4 centimeters. So anywhere along such a circle is 4 centimeters. Remember, we need the inner side because R should be less than 4. Then finally, from BRC being a triangle, we need area which is strictly greater than 12. Strictly greater than 12. So for the area to be strictly greater than 12, we will need to say that BC is already 8 centimeters. Then we are talking about area being 12. So we need a parallel line to this one, parallel line to BC on either sides, but such that if we project area there, we will get 12. So for us to get area of 12, we need half times 8 multiplied by a known height. So this height is going to be 4h equals to 12. So h will be 3 centimeters. So 3 centimeters away from BC. 3 centimeters away from BC. So we can do 3 centimeters away from BC. This line is 3 centimeters away from BC. And we do the same on the other side, 3 centimeters away from BC. 3 centimeters away from BC. So you see the shaded thing now is going to be here. The area is going to be somewhere there. And also on the other side. So that is how you're going to get the diagram. I'm sorry we are not having equipment for use on these soft copies, but at least I have illustrated such that you understand what is supposed to happen. Number 12, PQRST is a right pyramid on a horizontal square whose square base, whose side is 12. Just as you can see, the slant edges are all 10. Slant edges are all 10 centimeters long. Find the angle between the planes PQT, we can see that plane, which is triangular, and RST. You can also see that plane. They are all meeting at a certain apex, which is T. So the angle between two planes is when you draw an angle from where they are meeting to the base of each independently. That. So the angle at this point is the angle that we need. So if we can call this one X and this one Y, then the angle XTY is what we need. XTY. Remember, from X to Y, 12 centimeters. Let me extract now triangle XTY. If I have to extract it here, XTY. So I'm talking about XTY, 12 centimeters. What about a length like XT? Is it known? Not really. Can we know it? Yes, we can. Because following the triangle PQT, the first triangle PQT, we can see that from X to Q, this is 6 centimeters, this is also 6. Then now the slanting edge is 10. So the height which goes through TX can be found by saying 10 squared minus 6 squared. We just need the square root. This is going to be exactly 8. So this is 8 centimeters. So with 8 centimeters and 12 centimeters, and the angle of interest is the one at this point, then we can split it. this way, such that now we work with 6 and 8. So with 6 and 8, the angle at this point can be found using a sign, whereby sine alpha will be given by the opposite length, 6, out of the hypotenuse, 8. So that from this, we can say that alpha is given by the sine inverse of 4. Divided by 2, we get 3 over 2, sorry. 3 over 4. 3/4. So what is the sine inverse of 3/4? Shift sine 3/4. This is going to give us 48.59. 48.59. Now with 48.59, we are also supposed to ask ourselves, if that is that particular part, what about the whole angle now? X, T, Y. It will be 2 multiplied by 48.59. And when we multiply this by 2, exactly we are getting 97.18 degrees. So this is the angle of our interest, 97.18. That is the angle of our interest. Looking at number 13, raw data collected from experimental observation normally have errors. Below is a table of results obtained results from an experiment. The results show how length L in centimeters of a metal rod varies. This is varies, not various. Varies with increase in temperature. We know that with increase in temperature, we expect a length. We expect an expansion, so we will have an increase in length. Plot the values in the graph given below. In the graph given below. Yeah, so we can do that. We can have a plot the values in the graph, and they should be values of the best fit. Yeah, values of the best fit. You know, we can have any of these quantities on any of the axes. Actually, I can even have temperature. Yeah, I can even have temperature on the... I can have temperature even on the vertical axis. Let me do that. Temperature on the vertical axis. Any can occupy the vertical axis and the other on the horizontal axis, as long as you will relate them well. So we can have temperature here in degrees Celsius. Then we will have the length, the rod, on the x-axis. The length in centimeters. The length in centimeters that way. So for the temperature, which is running from 0 to 8, I can have from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that way. Then when you talk about the length is running from 4 all the way to 6. From 4 all the way to 6. So I can use intervals of 1 again. So 1, 2, 3, 4, 5, 6, 7. Yeah, let's reach there. Then we start plotting now. 4 against 0. 4 against 0. Okay, 4 against 0 that way. All right, there is something here that I want us to understand. when we use 4 against 0 that way, you will discover that there is no what you call a y-intercept for that line. We will not have a y-intercept. So we can change the quantities. Let me change the quantities so that I have length here in centimeters. Then I bring temperature on this scale. Sorry for that inconvenience. Temperature, which is in degrees Celsius. And that scale, this will be 8, 9, and such. So we can now begin with a coordinate like, change the plotting. Yeah, 0, 4. So 0, 4 comes here. Yeah, this is now making some sense. Then we can talk of 1, 1, 1, 4.3. So 1 goes with 4.3. And remember 4.3 is somewhere here. 4.3. Then 2 goes with 4.7. So 2 goes with 4.7. So 4.7 will be somewhere there. Remember, we are going to plot a line of best fit. 3, 4.9. So 3 goes with 4.9 in this position. 4 goes with exactly 5 that way. 6 goes with 5 goes with 5.5. So 5 goes with 5.5. What about 6? 5.9. 6 goes with 5.9, just below 6. Then 7 goes with 6.0. A temperature of 7 goes with 6.0. A temperature of 8 goes with 6.4. So 8 goes with 6.4. We have to do a line of best fit such that majority of the dots are accommodated by the line. Majority of the dots are accommodated by the line. Yeah, so let me connect them. So I just want to ensure that majority of the lines, majority of the dots are on the line. This is the line of best fit now. A few lines can be below, others above, but majority are lying on the line. Majority are exactly on the line that way. So this is what we call a line of best fit. Now with a line of best fit, we can now proceed to respond to the next question. Find the equation connecting L and T. L is the length, T is the temperature. So temperature T and length. So we know that because L is on the y-axis and we have plotted a straight line, y equals to mx plus c. We usually say that this is the quantity plotted on the y-axis. So we will have L there equals to m, and the value on the x-axis is t plus c. Then now with c and m as the constant, m is usually the slope. This is another name of gradient. C is usually the y-intercept. Y-intercept. So can we interpret the y-intercept? Yes, it can be read as 4, according to where the line is cutting the y-axis. What about the slope? We need to work out the slope now. For us to work out the slope or the gradient, we just need 2 coordinates, which are on the line. So allow me use coordinate 0, 4, and the coordinate 7, 6. Can use even coordinate 7, 6. Yeah, coordinate 7, 6, 0, 4, 7, 6. So change in y, 6 minus 4. Change in x, 7 minus 0. This will be 2 out of 7. 2 over 7, yeah? So when 2 over 7, it can even remain as a fraction that way. So now replacing them on the equation up there, we will say that L, which is on the y-axis, equals to gradient 2 over 7 multiplied by the value on the x plus a constant, which is 4. And the constant should be the y-intercept. That way. So this is how we get the relationship between the two quantities. We're looking at number 14. Determine the distance between the centers of the two circles, A and B, given that their equations are, we have the first equation and the second equation. But what are we calculating? Distance between the two centers. So the first center can be calculated, whereby we say we can group the x functions together first. In this case, we'll have x squared plus 8x. Then we will add a constant here so that we make it a perfect square. We add the y function, y squared minus 2y. Then you see the constant here, we can take it to the other side because for the y function, we also have to make it a perfect square. This is equal to -4, and we will have to add the two constants to the left-hand side, to the right-hand side. We add the two constants there. To make it a perfect square, the first constant will be given by b over 2 squared. So 8 out of 2 squared. This is going to be equivalent to 8 over 2. That's 4 squared 16. Then C2 will be -2 over 2 squared. This will be -1 squared, which is just 1. So we add it to both sides. Now we'll be talking about x squared plus 8x, then plus 16 plus y squared minus 2y plus 1. This is equivalent to -4 plus 16 plus 1. Yeah, so we have the x component being a perfect square, the y component being a perfect square. Now we need to take -4 plus 16 plus 1. This gives us a 13. So on this side, we have 13. When we are having 13 there, we need to talk about the x part, whereby we have to factorize. We factorize this x component now, whereby we take the square root of x, the sign which follows, the square root of the constant squared, plus, for the y function, we also factorize. To factorize a perfect square, we need the square root of the first part, which is y, the sign which follows, which is a minus, the square root of the constant, square root of 1 is just 1, also squared. This one is giving us 13. Yeah, 13. So now with this, we can get the first center. We know that x minus a squared plus y minus b squared should give us radius squared. This is the general equation of a circle. And if this is the general equation of a circle, whereby center is AB, then we can say negative a is the same as 4. Therefore, a is -4. Negative b is the same as -1. Negative b equals to -1. Therefore, b is 1. Therefore, center 1, the center of circle A is -4, 1. Good. -4, 1. So now we can talk about the second center, whereby we deal with the second circle. Second circle is having direction this way. You know, we cannot complete the square unless we divide by the constant through. Therefore, for this second circle, we will talk about when we divide through by 2, so that we get x squared plus 3x. We will have to add a constant here, plus y squared. But after y squared, now we have minus, instead of 10, 5y equals to, we add again a constant here, so that we also make that part perfect square. Then we will have 7 becoming negative, but now we will have to add C1 and also constant 2. How do we get constant here? The first one will be given by 3 over 2 squared. 3 over 2 squared will be, this is a 9 over 4. Constant 2 will be negative 5 over 2 squared. This is going to be 25 out of 4. So let's add both of them. X squared plus 3x plus 9 over 4 plus y squared minus 5y plus 25 over 4 equals to negative 7 plus 25 over 4 plus 9 over 4, the two of them. So we factorize the x component. X, the sign which follows is a plus, square root of the constant 3 over 2. We square this. We add y, the sign which follows is a minus, 5 over 2 squared equals to, let me compute this, minus 7 plus 25 over 4 plus again 9 over 4. This is 1.5. 1.5. So the center for B, center of circle B, will be 3 over 2, which is negative, to be negative 1.5. Then negative 5 over 2 becomes now positive 2.5. So that is now the second center. We have the two centers now. So from A to B, what is the distance now? Distance from A to B. We're supposed to find, first of all, the vector there. The vector AB, which is going to be, vector AB is going to be B, so negative 1.5. Let me write it as a column vector. So we talk of negative 1.5 minus negative 4. That's all, yeah. Then this one has to be having the other side as 2.5 minus 1. So this will be, when we take negative 1.5 plus 4, this will give us 2.5. Then 1.5. That's the vector. So for us to get the length of AB, we need 2.5 squared plus 1.5 also squared. Then we obtain the square root. So 1.5 squared, 2.5 squared, square root, we are getting 2.915. Because it's a distance, we write units. Yeah, that is it. So we have applied the equation of a circle together with vectors. Actually, the magnitude of a vector, which is in form 2, that is vector 1, because we are only having two components, x and y. The position vectors p, q, r are such that p equals to 2i plus 3j plus 4k. This is equal to negative i, negative 2j plus k, r, 5i, 8j, 7k, respectively. Show that the points p, q, and r are collinear. For us to show collinearity, we have to examine it in this way. We have to talk about any two vectors within the three provided. So we can talk about vector P, Q, and we also relate it with vector P, R. These are two vectors. Any two vectors can be expressed. So how do we get vector P, Q? We have to take Q, which is negative 1, negative 2, and positive 1. I'm taking the coefficients of the vector units or unit vectors, the coefficients negative 1, negative 2, and 1. Then we subtract Q, which is going to be 2, 3, 4. You see here, I am having negative 3, I'm having negative 5, And I'm having -3 again. -2 minus 3, -5, -1. Okay, 1 minus 4, -3. So that is the vector. Let's talk about vector PR, whereby I would need R. 5, 8, 7. 5, 8, 7. 5, 8, 7. Yeah, 5, 8, 7. Then with the 5, 8, 7, we can talk about P, which is 2, 3, 4 again. So I'll be having 3, yeah. Then from there I have 5. Then here I talk about 3. Yeah, you see now the vector PR and vector PQ can be related. If we assume that PR equals to a constant multiplied by PQ, then we would say 3, 5, 3 equals to a constant -3, -5, -3. So that -3K equals to 3. And the value of K is proved to be -1. Even when we use the X component, -5K will be equal to 5. K becoming again -1. And when we use the Z component, we get the same. So K is negative. So through this, we can say PR is the same as the negative value of PQ. That way. That's how the two are related. If one vector can be expressed as a scalar multiple of the other, then it means the two vectors are parallel to one another. So we say that PR is parallel to PQ. And out of the two vectors, P is a common point. A common point. Hence, P, Q, and R are collinear. So collinearity is usually shown when you confirm that two vectors amongst the provided positions or position vectors, two vectors are parallel to one another, and one point of the two vectors is a common point. Then we say that collinearity is there. The diagram below shows a line OA. Draw a circle of radius 3 centimeters using O as the center. Using O as the center, we draw a circle 3 centimeters. So we have to stand there and use 3 centimeters. Yeah. 3 centimeters this way. Remember, the circle is just a sketch. We don't have tools which can be used to do a perfect circle here. We don't have tools for a perfect. So we just estimating a circle that way, 3 centimeters. Then from there, we are further given more instructions. I hope you remember that our consultation line is here. 07, 04. Sorry. Should check what is happening. Yeah, our consultation line is paper is not responding well, sorry. I'm checking what the issue could be. So let me adjust the ink and use maybe blue. Yeah, so we see this. Okay, so I'm fixing the issue. So we're saying our consultation line is 07, 04, 15, 3366. So kindly use that number to reach out and to know what we are trying to do here. The next, we are saying that a point P lies on the line. It lies on the line AO such that a tangent from the point P to the circle makes an angle of 30 degrees with line OA 30 degrees. So we need a certain tangent whereby there is a point P somewhere along OA and that it will make 30 degrees. You know, something that you're supposed to know is that if it will make 30 degrees then, and we know that a tangent has to make 90 with a radius. You know, if we draw a radius here from the center this way, if we draw a circle that way, a radius there, making 60 degrees here, then we are supposed to know that if this line is extended, we just have to extend it a little bit. If we extend it that way, the tangent from point P should be perpendicular at that particular point, at the particular point here. Therefore, we stand at that point and we make some bisector, which is perpendicular now, that way, such that now if we draw this bisector, which is now perpendicular at that point, it will take us to a point that we will now have it as our P, because P now will automatically make 30 here, and it is supposed to be perpendicular at this point. So automatically we had to begin with the 60 degrees here. So we have identified our point P, because we are told by construction, locate point P. So that is how you are supposed to reason around that question. Thank you so much for finding time to follow up with this live broadcast. See you next for section 2. Thank you so much.